Hello everyone, my name is Sudaratsi Philom. I'm going to talk today about characterization and electrical property of barium titanate based ferroelectric dope lanthanum. This research studies ferroelectric and thermoelectric properties. Barium titanate is ferroelectric oxide. There are electrical properties such as dielectric and ferroelectric properties, but it has a high electrical resistivity, which is unsuitable for application as a thermoelectric material. Therefore, the researcher is trying to find a way to improve this substance to have a lower electrical resistance, for there is the ability to electrical conductivity is increased while still having dielectric and ferroelectric properties. I would like to show theory in this research. Thermoelectric property. Thermoelectric material is material that can convert heat energy into electrical energy. The performance of thermoelectric material requires high conductivity and low thermal conductivity. By this equation figure of Molich, and S is the Seebeck coefficient, sigma is the electrical conductivity of the material, K is the thermal conductivity of the material, and the power factor, which is a measure of the efficiency of thermoelectric material. Ferroelectric property. You can see hysteresis loop in ferroelectric material, and PS is saturated polarization, PR is remnant polarization, and EC is coercive field. In ferroelectric crystal, there are regions of polarization in the same direction before the dipole electric field was dispersed. After the electrical field is applied, dipoles are aligned with the electric field, causing polarization. Barium titanate. You can see the change in the structure of barium titanate relationship with temperature. Barium titanate is a compound with interesting properties such as dielectric constant and ferroelectric properties. Barium titanate is a ferroelectric material. It can undergo a variety of crystal structure transformation with changing temperature, and dielectric constant will depend on temperature, and there is a maximum value at Cooley temperature. The temperature in which the phase transition from tetragonal to cubic is called Cooley temperature. And next, preparation of the substance, synthesis barium titanate and barium titanate doped with lanthanum, and X is lanthanum concentration. It was pellet by hydraulic press and sintered at a temperature of 1300 to 1500 Celsius for 2 hours, and analysis by X-ray diffraction, SEM, LCR meter, ferroelectric hysteresis loop, Seebeck coefficient and power factor measurement. You can see the XRD pattern of barium titanate doped lanthanum. The peak was found according to the JCPDS, and the structure is more cubic, evident at x equals 0.04 and x equals 0.08. This is the SEM image of barium titanate doped lanthanum. Grains are spherical or polyhedral scattered together, and the grain size decreases with increasing lanthanum concentration. Dielectric constant and dielectric loss. You can see the relationship between temperature and dielectric constant and dielectric loss at frequency of 1, 10, and 100 kHz of barium titanate doped lanthanum. But x equals 0.04 and 0.08, it cannot show in this temperature. This is hysteresis loop of barium titanate doped lanthanum, and barium titanate doped lanthanum is a ferroelectric material, and x equals 0.02 will have the highest residual polarization, exhibit high ferroelectric behavior. You can see the graph of the relationship between temperature and resistivity, and the graph of the relationship between temperature and power factor of barium titanate doped lanthanum. The lanthanum dope content at x equals 0.01 are low electrical resistivity and the highest power factor. This research found XRD pattern of barium titanate doped lanthanum show the peak was found according to the JCPDS, and SEM image of barium titanate doped lanthanum show grain with a spherical or polyhedral morphology. The grain size decreases with increasing lanthanum concentration. LCR meter was used to determine the electric constant. It was found that electric constant decreased with increasing doped lanthanum concentration. Polarization behavior reveal lanthanum doped barium titanate compound, which are ferroelectric material. Power factor represent the thermoelectric behavior of barium titanate doped lanthanum. This study was found that the electrical resistance and power factor were affected by doped lanthanum concentration. And finally, the lanthanum dope concentration at x equals 0.01, there are low electrical resistivity and the high power factor.